Algebra 2 skills number 39, finding inverses of functions. Let's take a look here. So first we're going to look at our steps. If you are given a function in function notation, f of x, it may be another letter, g of x, h of x, whatever. This is just the name of the function. You want to change that over to y. Just makes it a little easier if you do. You then switch your x and your y, and again, sometimes it may be different letters, but generally it's going to be x and y. Solve for y, solve for what is now not isolated. Then we want to change it back to inverse notation. If you started with an f, this is inverse notation. F inverse of x is how you read it. It looks like a negative 1 exponent, but it is not. It is just a notation there. So let's look at some examples. Simple linear function, f of x equals x plus 6. Going through our steps, change f of x to y. Notice the coloring here. You then switch x and y. You then solve for that y, that new y there. So you're going to subtract 6 from both sides. And then we want to rearrange and put it in this function notation. F inverse of x is equal to x minus 6. Now the purpose of an inverse is basically to undo something. So if you put a number, just choose some random number like 2. If you put 2 into this yellow function, 2 plus 6 is 8. If you wanted to take that 8 and get your 2 back, you would put an 8 into this blue function. 8 minus 6 goes back to 2. So an inverse function basically is an undo feature for a function. Second example, a little bit more complicated here for this linear function. F of x equals 2x minus 1. Again, change f of x to y. Again, switch x and y. Here we have 2 steps, get y by itself. We first add the 1 over, so that 1 goes over there. We then divide by 2 to get this look. Now there's another look here. Let's go to the next slide. All right, that's where we left off. You will sometimes see that 2 get split and make it into slope-intercept form. So you may see it left like this, you may see it in this form. Just take note of that. Again, we tidy that back up into this nice inverse notation. The third example, again, we'll keep it linear for this video. Change f of x to y, switch x and y. So we have to get rid of the 4 and the 2/3. So next slide. Again, this is where we left off. Let's get rid of that 4, so we subtract 4 from both sides. Now this 2/3 here is a little annoying. You could get rid of it in 2 steps, but if you want to get rid of that all at once, you multiply both sides by the reciprocal. The reciprocal of 2/3 is 3/2. So notice the difference there, and multiply by 3/2. By definition, reciprocals are 2 numbers whose product is 1. So next slide, this is where we left off. These 2 are going to multiply to 1, leaving y isolated. And notice on the left-hand side, 3/2 times x is 3/2 x. 3/2 times negative 4, well, that's negative 12/2 or negative 6. And again, we tidy that back up into this nice inverse function notation. This is red. F inverse of x equals 3/2 x minus 6. Now it's worth mentioning here that the graphs of inverses are going to be symmetric about the line y equals x. So looking at a nonlinear example of this green dashed line is the line y equals x. This blue function is the square root of x. This red function is half of the function f of x equals x squared. But those are inverses, and notice how symmetric that blue and that red is along that green line. So anytime you ever graph a function and its inverse together, you should get 2 functions that are symmetric about the line y equals y equals x.